All right. This is just to let you know. All right. We will still have our so-called just a 1 hour workshop on GC, which I plan actually for the first lecture once the new timetable begins. Okay, so go and get a copy of the GC workshop notes. It will be a hands-on practice, so please bring your GC along as well. Okay, there are some very essential skills that we need you to be able to do. Okay, all right, and then it's more frequently used. Okay, and these are things that you already know, so that will be the focus. Okay, there will still be GC skills taught throughout the year as you actually know new content. Okay, but these are some of the very basic ones that you should know. Okay, because otherwise you go there and you don't know what to do. Okay, so please get it. It's 32 cents. Please get it before the next lecture and bring your GC. All right. Okay, let's continue. All right, last time we were talking about method of differences. So I just want to just very quickly summarize it. And then what happens is this: if we want to find, for example, the sum of terms, let's say UR from U1 all the way to UN. Okay, but this term any one of these terms can be written in general as f of r minus f of r minus one, where you notice there's actually a shift, right? Then what happens is this: we can write out the entire thing and then see which term cancels, and then finally evaluate this sum. Okay, so that was what we were talking about for method differences. Okay, I did one example, or I went through one example. I showed you how it's done. And then I was on the way to actually completing the second example, right? So let me just very quickly go bring you through it. It says by consider example 10, which says by considering UK minus UK plus 1, where UK is this, find Sn, okay, which is this. You notice that Sn starts from k equals to 1 to n. So we first already found UK minus UK plus 1. We actually found that this was actually equal to 2 over k plus 1, k plus 2. And then, but because this thing inside here is actually 1 over k plus 1, k times k plus 2, so I actually divided both sides of this equation by half so that these two are equal. Then what I did was this, because this was equal, okay, and I want to actually find Sn, which is the sum of k of the k of these terms from k equals to 1 to n. So what I am doing here is basically summing on both sides from k equals to 1 to n. Okay, all right. And then the idea is that this thing here on the right hand side will be Sn. This thing here, I can actually expand it out and write it out using method of difference. And so I hope you've actually tried to do that. So now this is what I will be doing. Okay, so let's finish this off. Okay, so in this case, this is Sn. All right, now how do we write this out? Very similar. You write the half outside first, then UK and then UK plus 1. Okay, so you substitute for k equals to 1 first. So this is U1, okay, minus U2 plus, please make sure you put the plus, U2 minus U3. So this is the first line is actually for k equals to 1. This is k equals to 2. And then this is k equals to 3. Okay, I'm not going to write it out because in the actual exam you cannot write it out, but you should have the idea. Now, the first thing you need to do is this. You ask yourself how it's actually going to be cancelled. You can see that the cancellation actually works this way. Okay, so the cancellation will probably work this way. Now, if you want to write 4 terms, you can write 4 terms. Okay. Then because you have actually written 4 terms, you now need to write 4 terms below. So you know that when k equals to n is the basically has the last line. So this is un minus un plus 1. The one above it must be un minus 1 minus un minus 2 minus un minus 1 and un minus 3 minus un minus 2. So you can see the cancellation should work like this. Okay. Now next, very quickly, notice that there's one term here and one term here. So pretty much that's what it should be. Okay, so therefore, let me just zoom out a little bit so that you can see the working at one go is a bit high. Okay, so you can see this, you can see that basically your Sn, okay, so I can rewrite this, Sn is actually half U1 minus U n plus 1. Now, you do know what UK is, okay? Now, your UK was basically here, right? So in this case, for U1 and UN, you substitute the corresponding values of K, okay? So in this case, what you get is, it's 1 over 1 times K plus 1, so that's 2, minus 1 over N plus 1, N plus 2. Let me just check if the answer is correct. Okay? Yeah, you're right. Okay, so just tidy it up. Some of you may want to go and simplify it, but this I think will be that should be fine. Okay. All right. So essentially, there are a few things I just want you to review a little bit. There's one very important skill here that I purposely did it in this manner. Okay, which is actually this portion of summing on both sides from k equals to 1 to k equals to n. So this is an important skill you basically need to take note of. Okay, can this is a bit different. Yeah, I purposely did it in a different way because this is actually more frequently used. Okay, it's a very frequently used technique. All right. If you are done, let's move on to the next portion. Let's move on to section 7. You need to see this part, is it? Okay, this one I'm just writing out for you. Usually I just say it, but essentially you should be summarizing in your own words. You can just look at this is just an example of how I would do it. Okay, but you should try to summarize it, understand the concept, and try and summarize it. Okay, let's move on to the next section, which is limit of series. Okay, now this is a very important. Please take note of the logic of how the argument goes, because and this is where sometimes your language and how you actually present, how you actually say certain things makes a difference. Okay, now any series Sn where Sn is actually U1 all the way to Un that approaches a finite limit S as n tends to infinity. All right, so in other words, actually, if we were to use the language in the beginning of the chapter, essentially it's saying as n tends to infinity, as n tends to s. Or sometimes we write it as limit as n tends to infinity of Sn must be equals to s. Okay, so notice this, I'm just rewriting the language which I talked about previously. Okay. Now, obviously, remember from our previous discussion that obviously if the limit exists, which is s, okay, is finite, then we say that Sn is a convergent series. Okay, and more importantly, S is its sum to infinity. Why do we call it the sum to infinity? It's because I'm summing an infinite number of terms and it goes to a specific value. Okay, if the sum to infinity you find, oh, it is infinity, it diverges. It's not a specific number. Remember, infinity is not a number. I want to repeat this. Infinity is not a number. It's a concept. Okay. All right. So your S actually is U1 plus U2 plus U3 all the way up. All you see this dot 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 means I'm summing to infinity. So the logic goes this way. If I can find the limit as n tends to infinity of Sn, if I can find this limit and it exists and it is finite, I say that the series converges. If this does not exist or is infinite, then the whole series diverges. Okay, only two concepts. It is either converge or diverge. Notice the logic. When you explain this, you have to be very clear. The logic has to go this way. Find the limit first, then conclude that it converges. Not converge and then find the limit. No, it's the other way. Okay. Right. So how do you determine whether a series converges? First, go and find what we call this is actually what we call the partial sum. Okay, partial sum from 1 to n. Okay, I let it be Fn. So it will be in terms of n. Now you can do two methods. One, actually use the property of formula for the sigma notation in section 4, or number two, use the method of differences. So you now begin to understand why we actually did the method of differences. Okay. Now part 2 says is, and part 2 is, this portion is actually more to find Fn. Okay. So step 1 actually is to go and find Fn. Next, determine what happens to Fn as n tends to infinity. Okay, that means I basically now need to go and find this limit. The question is, can I find this limit? If the answer is no, okay, then the series diverges. If the answer is yes, the series converges. Okay? Alright, so this is basically what this line here basically tells you. Basically, this line basically decides and tells you whether or not you can conclude whether a series converges or diverges. Okay, so let's look at like example 11. Example 11 is a fairly straightforward example. I think this was done previously. Okay, now they say, you notice this is actually this whole thing here is actually an infinite series. Okay, so now we ask is this a convergent series? Now, obviously, it doesn't make sense to talk about whether or not, if the series is finite, it doesn't make sense to talk about whether it's convergent. Okay, because obviously it will converge. Okay, the only question you want to ask is it convergent if I add an infinite number of terms? Okay, so what actually happens is this. We realize that this example actually is the same series as example 9. So if we go back, I'm not going to return too much to example 9, but from example 9, you can see the answer. So I will just make reference to it. I do know that from example 9, okay, this series from r equals to 1 to n of 1 over r plus 2 is 3 over 4 minus 2n plus 3 over 2. I'm just copying it down because we need this first. Okay, now we've got this result. This is basically from example 9. So essentially, the first part of basically example 9 deals with step 1. That was basically what it's doing, okay? Because I had defined this sum from r equals to 1 to n in terms of n. So that example 9 has done part 1 for us. Now, for part 2, oops, okay. Let's hope, just give it some time. Okay, so for part 2, what you need to do now, all right, is to go and find the limit. Okay, so what you need to do now is to go and find the limit. Okay, so how do you find the limit? So what you can do is this. You say limit as r, in this case it's n tends to infinity of this sum okay, is the same as saying the limit as n tends to infinity of this whole thing. Okay. Now, what happens is this, you can split this up. So this is limit as n tends to infinity of 3/4 minus the limit as n tends to infinity of 2n plus 3 over 2n plus 1 and plus 2. Now, few things you can do here. Okay, one is that you should recognize the limit of 3/4 must give you a finite number. What about this fella here? It must give you 0. Why? Yes, but that's also true for the numerator too. That's not good enough. Okay, that's a nice try, but it's not good enough. You need to know there are a few things you need to observe again. So let's go back to where what we had. Okay, the numerator, notice that the numerator is 2n plus 3 and the denominator is 2 is basically a quadratic. So it is a proper fraction, correct? Okay, so because it's a proper fraction, okay, what actually really happened? So I'm going to explain this a little bit in I'm not going to say this is not really mathematically, this is the intuition behind it now. Okay, now if you look at the top 2n plus 3, it is increasing what we call linearly. That means you know for the if you go and sketch a curve, if you go and draw two graphs, right? The top one is basically a straight line. The bottom one is actually basically a quadratic curve. Now, a quadratic curve, if you go and sketch a graph, you realize that, I mean, you know this from secondary school. If your n gets very, very large, what happens? It shoots through, right? It becomes much, much higher than the linear portion, right? So if it's much higher than linear portion, as n tends to infinity, your denominator becomes very much larger than the numerator. So in that sense, your denominator, okay, increases much faster. But because you are dividing, this whole thing must go to, if you are taking a number that's increasing slowly versus a number that's increasing much larger, that whole fraction must go to 0. Okay, so actually that's how we really think about it intuitively. Okay, so in this case, because we know that this limit here is 0, then we will just write because limit as n tends to infinity of this okay, so therefore this must give me 3/4. Okay, now let's look at example 12. Example 12, I know some of you can go to YouTube and go and search on this. I know a few years ago, a lot of students used to kind of ask me, Mr. Pio, so and so managed to prove to me that this whole series, right, is equals to negative 1 over 12. Okay, actually by the way, those mathematicians, inverted commas, basically they were theoretical physicists, are right if you are talking about the quantum world. Okay, I happen to be a quantum physicist too, so I do know. Okay, okay, I know what assumptions they have made lah. Okay, but mathematically they are not. It is not exactly correct. Okay, mathematically not exactly correct. So I'm going to, for this example, going through this example with as a mathematician, not as a quantum physicist. Okay. All right. So now the question is this: does this series 1 minus 1, 1 minus 1 converge? Okay. I.e., does the sum of infinity exist? Now, what happens is this: you realize the following things. Okay. Now, if you actually, for example, you realize that Sn must equal to 0 or 1, depending on whether you stop, whether how many terms you have. If you actually stop at the odd term, all right, so let's say for example the third term, you realize the answer is 1. Okay, but if you stop at even terms, notice that the 1 and the negative 1 will cancel, so therefore the answer is 0. So essentially your Sn must be 0 or 1. Okay, or sometimes you actually write it in this way. This is actually the mathematical way we write it. Okay, this is actually the mathematical way we write it. Okay, so you realize there are two possibilities. Now, because there are two possibilities, we know that this limit does not exist because you can't tell it. You can't tell. Your infinity is you don't know whether it's an even number or an odd number. Okay? So because we do not know, it doesn't have a limit, it doesn't have a specific limit, okay, we therefore say that the series does not converge. Okay? So basically in line with what we have always been saying. Okay, if I have time, I will go through this question, which I might have today. All right, but let's move on to, I think I've already done my part for this portion. Let's move on to the miscellaneous examples, but it's not really miscellaneous. Okay, it says example 13 involving evaluating a sum using the substitution method. Now, example 13 is a very, very important example. Okay, I always test it in exams. The question is you do not know whether it's going to be tested in common test, MSA, or final exams. Okay, my favorite. Tell you already, don't say I never say. Okay, um, now let's take a look at this method. This is not really a miscellaneous example. This, remember the miscellaneous example, please cancel the word miscellaneous. It's just an example that is important. Okay, now A part 1. Express this in this form A over 2R plus and so on. Okay, or they could actually just tell you express it in partial fractions. Okay, now always make a habit to read the whole question first so that you have some sense of what's going on. Okay, hence find this sum. Okay, so you realize, look at this very carefully. You will see that this thing here and the last term here and probably this term here has some link. All right, and quite likely you need to use the partial fractions and hence deduce this. Actually, when you look at the partial fractions, you should like sort of like think to yourself, I might be able, for this question, I might need to use method of difference. Okay, so quite likely your A and the B will be one positive and one negative. Okay, so I'm just telling you some of the thought processes that I have in the back of my head. Let's carry on and do this example. Okay, so let's do the first portion. How do I do partial fractions? Okay, you've done this for the test, so we won't. I won't belabor the point, but I'm going to write this the way I would expect you to do this partial fractions as in the A levels. Okay, so you will realize that the working will be a bit different because you need. I'm going to assume you have the ability to use your GC. Okay. Right. So in this case, therefore, 1 is equals to 2AR plus 2BR plus 3A minus B. Okay. So actually, I'm doing comparing coefficients. 2A plus 2B equals to 0. So this implies that A must equal to negative B, or A plus B should equal to 0. I'm going to write it this way first, because later you can actually use your GC to find that out. And finally, 3A minus B equals to 0. Okay, so I put this as equation 1 and equation 2. Okay, and later what happens is this, I will use this and use these two and solve using GC. So I won't do it for you. Okay, but I'll just say from GC. Okay, I'm writing it this way so that you would later on, when you come back and see and understand, once you've done the GC workshop, you understand why we are writing it this way. Okay, so from GC what you get, I think, is 1/4 and negative 1/4. Okay, so I think A is 1/4 and B is 1/4. Okay, so give me a moment because Word is not cooperating with me. Okay, so okay, right. So you still have to answer the question because they ask you to express it in that form. So you have no choice but to write out the entire thing. Okay. All right. Let's see whether more space. I probably don't. All right. I think I better take another sheet of paper. Okay, let's look at the second portion. It says, hence find the sum of this. Okay. Okay, now what would be good here is if you could actually see that this sum could be written as the summation, right? Okay. In this case, now notice that the last term here is n, so that means I choose another letter. So in this case, you could choose I or R, up to you. But in this case, I choose R. Okay, because you're so used to R. Okay, so R equals to 1 to n of 1 over 2r minus 1, 2r plus 3. Now, whenever you write this in terms of a summation, the next thing you need to do after you're done here is to go and check. You substitute r equals to 1 inside here. Does that give you 1 times 5? Correct? Does it give you 1 times 5? Does it correspond to the first term? R equals to 2, does it correspond to 3 times 7? R equals to 3, does it correspond to 5 and 9? And R equals to n, does it correspond to this? You should check. Okay? So please check. Okay? Alright, because if you get this wrong, obviously something is wrong with you. Is done. Okay, now what happens is this. Because I've already been asked to write this as partial fractions, okay, so I now need to write this whole thing as partial fractions. So it's 1 over 4, 2r minus 1 minus 1 over 4, 2r plus 3. Now, obviously, please do not go and cancel it out first. Please learn to factorize and simplify. So you realize that I should take out the 1/4 so that it's less cumbersome. Next, this obviously, can you see this is 2r minus 1, this is 2r plus 3. Obviously, this is a shift. Okay, so nonetheless, you should write this out. Okay, so r equals to 1. This gives you 1 over 1 minus 1 over 5 plus 1 over 3 minus 1 over 7. Okay, and then you realize you need to carry on. So 1 over 5 minus 1 over 9. Okay, and then you have 1 over 7 minus 1 over 11. Okay, you realize the cancellation works this way. And you see it's by a difference of 2, right? Which actually should be the case, because if you actually multiply it by, let's say for example, you realize that yeah, the thing basically cancels two values away. Okay, so you notice this will cancel. You've got 4 terms here. Please make sure you write 4 terms. Okay, so I'm going to write it backwards. This is 1 over 2n minus 1 minus 1 over 2n plus 3. Then this is r equals to n. R equals to n minus 1. That should give you, I'm going to write it this way, 2n minus 1 minus 1 minus 1 over 2 n minus 1 plus 3, 1 over 2 n minus 2 minus 1 minus 1 over 2 n minus 2 plus 3. Okay, so my classes were too close, so let me just change this. N minus 3 minus 1 minus 1 over 2 n minus 3 plus 3. Okay, so where does this cancel? You will see that this 2n minus 1 would correspond to this fella here. Here you see 2 times n minus 2 plus 3. Because 2n minus 2 is actually 2n minus 4 plus 3. So 2n minus 1, 2n minus 1. Now just you need to check. This one is 2n minus 3. This one here would be also 2n minus 3. So it's 2n minus 6 plus 3. So that's 2n minus 3. So this point also cancel. So I mean you can work out the rest, but you should expect that basically this cancel as well. Right? And this one is when you substitute r equals to n minus 2 and r equals to n minus 3. So this one portion here is annotation. Please work it out. Okay, now a very important thing, there's a bracket here. I bracketed it, so I make sure that I close the brackets. Okay, now few more things. Two terms here, two terms here. Make sure that you have the negative signs for those as well. Right? So in this case, this is 1/4. 1 plus 1/3 minus 1 over. Now I can simplify this. This gives me 2n minus 2 plus 3. So that's 2n plus 1 minus 1 over 2n plus 3. Alright. You can multiply this thing in. This is 4 over 3 times 1/4. So that's 1/3 minus 1 over 2n plus 1 minus 1 over 2n plus 3. Oh, sorry, I forgot the 4. Okay. Okay. Now this is pretty much standard MOD. It's part 3 that's a little bit more difficult. Okay. So hopefully you're done with this. You have to copy down some of the intermediate steps. I think some of them you can actually work it out yourself. Okay. Now, the part 3 is the main one that I want to go a little bit more slowly because it's the key thing that I want to talk about. Okay, which is basically evaluating a sum using the substitution method. Okay, so part 3 is basically the substitution method. Now, let's look at the question carefully. Yeah? It says, deduce this sum. Now, this sum, as we already know, was r equals to 1 to n of 1 over 2r minus 1, 2r plus 3. Okay? So, we know what this thing is. We already know what this thing, what the formula is for this. But now we want to use, because of the word deduce. Deduce means, and I want to repeat to you, these are very key action words. Deduce means you must use the previous results. If you go there and go and redo the method of difference again, go and do partial fractions and redo the method of difference and get the final answer and you're very happy, you get 0. I repeat, if you go and do the partial fractions again, the whole thing, partial fractions, then go and do a method of difference and find the answer correct, but no marks. Why? Because you did not use this result. Basically, it's either part 2 or part 1 or part 2 result. Okay, to help you find this. What you did was redo the whole question. Okay, that's why this action word here, deduce, becomes very, very important. Okay. Alright, so essentially it's about looking at the following things. It is basically looking at this particular sum here, looking at this term here, and looking at this, and asking yourself, okay, what exactly is the what's the word to use? What exactly are some of the differences and similarities? So while I transfer some of these things there, I want all of you to look at it first. I'll give you some time to look at it first, and then tell me what are the differences and similarities, okay, of part 1 and part 2. Okay, which is I think here. Okay, I'll talk about it in general first before we begin the method of substitution. Okay, what do you notice between these two things? What do you realize? Sorry? Yeah, you realize that basically the denominator, you see if you replace your r with r minus 1 actually. Okay, is it r minus 1? I think See, okay. So before we do that, we also need to know what we want to get to. Okay, we want to find this value. So therefore, I must transform this to look like that to apply part 1, part 2 result. Correct? So the question is this: how do we transform this such that this will give me 2r minus 1, 2r plus 3? Is by replacing my r with r plus 1. Okay, let's do this. If I replace my r here with r plus 2, what do I get? 2r plus 2 plus 1, 2r plus 2 plus 1. Does it give me the answer? 2, this becomes 2r plus 5, and this becomes 2r plus 9. So is it r plus 2? No. What do you think you can do? I'm going to spend a bit of time. What do you think you can do? 2r plus 1. Okay, some people say 2r plus 1. Let's try. 2r plus 1, I get 4r. R plus 1. Okay, so now I've got another suggestion. R plus 1. Okay, so does r plus 1 work? Let's see. R plus 1. So this gives me 2r plus 2 plus 3, right? So will it give me 2r minus 1? No, right? Okay. So therefore, you realize that some of you are beginning to get it already. Some of you realize that I should do r minus 1. Okay, some of you are beginning to realize that it's actually r minus 1, because if you get r minus 1, okay, if you work it out, that begins to give you 2r minus 2 plus 1, so that gives you minus 1, and then this one gives you 2r plus 3. Okay, so you would have to do a little bit of what I call scratch work in the beginning. Okay, so to sort of like identify the substitution. Okay, all right, so let me now do this. How would you need to write it out? Now this is the first part. So you know that I got to replace my r with r minus 1. So that's the idea. Okay, but we won't write it this way. This is how we write it. So let me just start a new one. Page. Okay. All right. So how will we write it? So I first start off with what I want to find, which is r equals to 1 to n of 1 over 2r minus 1, 2r plus 1 to r plus 5. Okay. Now, remember just now we identified that it was replace my r with r minus 1. Okay, so now let's do this. Actually, the way I would do it is this. That's why we call it substitution. I let a new variable be k. K equals to r plus 1. Then my r must be equals to k minus 1. Okay, now what am I going to do? This gives me, if r is equals to k minus 1, I substitute it in. Okay, you should be able to see, I'm just going to leave the limits out for the moment. Okay, I simplify this first. You are going to see that this will give you 2k minus 1, 2k plus 3. So which is basically what was part 2, right? Just that the variable changed only, it just became k, right? Okay, so dummy variable, you don't really care. Now, because this one was actually r equals to n, r equals to 1, this is r equals to n, okay, and this one here, the index, I've actually changed the index to k, so now I need to go and find what's the limits for k. Okay, so what do? I let r equals to 1, so when r equals to 1,
1 equals to k minus 1. So that means my k must be equals to 2. If I let r equals to n equals to k minus 1. So that means k must be equals to n plus 1. So I do know, therefore, this one must be r is equals to, k equals to n plus 1. Okay? And then I just put the necessary limits. Okay. Now, once I get this, so you notice the first thing that I did. The first thing I did was, I made sure that the general formula here, okay, let me see general formula here, was transformed so that it looked like that, which is what was in the previous result. The second thing, after I ascertained that this is true, then I did the substitution here, okay, and replace the limit. Can you see how it's done? Please annotate yourself. Step 1, what do you do? Okay, step 1 first, change the general formula such that so that you can identify the correct substitution that will lead you to the correct general formula as in part 2. Next, once you identify this correct substitution, which is this one, and this one, then after what you do, go and change the limits. Now I will tell you this, a lot of people in their haste always forget to change limits. Okay? A lot of people in their haste will forget to change limits. Make sure you remember. Okay? Now, once we are done with this, very important. Now, you notice that in this case, right, this one k already is a dummy variable. Now, I start from k equals to 2. If I go back to my formula, I start from where? K equals to, r equals to 1. So in this case, what I need to do is, before I apply the formula, I need to ensure, using one of the summation formulas, that I need to make sure that it starts from 1, so that I can apply the formula. If it starts from 2, I cannot apply. Okay? Repeat. If my k starts from 2, and my previous formula starts from 1, cannot apply. I must change, make sure that the lower limit is the same first. Usually it's 1. Okay? Sometimes 0, but most of the time it's 1. So I change it by writing it as k equals to 1 to n plus 1 over 1 over 2 k. Okay, let me just write it properly. Now, because I have, you notice that what's the difference between these two summations? The difference between these two summations is I've actually added the first term, right? So because I added the first term, what must I do? Yeah, I need to subtract. Or you can apply the formula also, but it's kind of, let me just naively do it. Okay, so that some of you do not get confused. But for those people who know and can see what's going on, you will see that actually what I've done is I added one term, I subtract away another term. Okay. Now this thing here, obviously, if you substitute k equals to 1 means only one term Okay, that means you're going to sum from k equals to 1 to 1, means i.e. only k equals to 1 Okay. So in this case, you find that this one here you just substitute k equals to 1, so that gives you 1 over 2 times 1, 2 times 1, so that's 1 times 5. Okay, so that's what you need to subtract away. Next, how do I do this? Now, my formula, my sum, right? Okay, so let me just go back. My sum here, this sum here was actually, let me just write this out. R equals to 1, whatever this is, to n. Notice it stopped at the n term. Okay, but for this particular case that we have here, this one actually stops at n plus 1. So what do? I just see the n and I replace it with n plus 1. Okay, so very simple. Replace because this one ends at n plus 1, just replace your n with n plus 1. So what would be the final answer? This is 1 over 3 minus 1 over 4 Now this was 2n, right? Plus 1. So it's 2n plus 1 plus 1 minus 1 over 4, 2 times n plus 1 plus 3. Okay, so this one is basically just want to let you know, replace n with n plus 1. Okay, because the upper limit here stops at n plus 1, not n. Okay, but you must always check that the lower limit is 1. Okay, all right, now let's tidy things up. Okay, so I'm not going to do the algebra for you. You can go do it yourself. But the final answer, finally, when tidying up the algebra, should give you something like this. Okay, what I'm going to do here is this. Because this is such an important method, I'm going to pause here for a while. I want you to read through it. Okay, 1 to 2 minutes, read through it, internalize, and then, if necessary, please raise your hand and ask your question. Okay, I have a bit of time now. I better do it now. Okay. Yes. So I mean, obviously it must be because it's going to be infinite series. Then you know whether or not it's going to if that different number of things, right? So whether it's going to be like no, so you must go and find out. That's why we're talking about that. This one was okay. Are there any questions about this method? I want to focus on this method first. Okay. Are there any questions on this method? Just shout out. Okay. You won't get this immediately. You need to go back and do some thinking. Okay, and then we need to discuss with the tutor. Okay. Two over 15 comes from 1/3 minus 1 over 5. Yes. Which property? Property E is it for this? Is it? Okay. Good question. So one of you actually asked whether we should actually use can always use property E. The answer is actually for this particular case you need to use property E because okay your original limit the starting point was 2 but the previous
Okay, the previous part in part 2, right? I actually started from r equals to 1. So I must use that property. Okay, otherwise I cannot use the formula. That means what I mean by that is I cannot use this formula. That means this result here. Okay, I cannot use this result. If I cannot use this result, then basically I haven't deduced from part 2. Okay, so it's important. So good question. I need to make sure that after I change my limits, usually there will be, it doesn't start from 1 already. So quite likely you're going to use part 2. Okay. All right. I think I don't have very much time to actually do another example because it's 11 o'clock. Is it half an hour? 1 more minute. Yeah. Okay. So I will actually stop here. All right. Actually, this I ended quite nicely on the dot. Okay. All right. First, before you go, everybody, take your phones, take your attendance. Okay. Put in your seat number. Okay. Log on now. Put in your seat number.